Rising more than 1,000 feet into the mist, clinging to the vertical wall of a sandstone tower, is a machine that should not exist. 3 glass elevators, sheathed in steel, climb the raw face of a cliff inside Zhangjiajie National Forest Park in Hunan, China. Around them stand thousands of towering quartzite pillars, ancient columns of stone draped in green, the same otherworldly peaks that inspired the floating Hallelujah Mountains of the film Avatar. And bolted directly onto one of them is the Bailong Elevator, the tallest and heaviest outdoor elevator on Earth. This is the story of how engineers attached thousands of tons of steel and glass to a fragile, crumbling cliff without tearing the mountain apart. To understand the audacity of this build, you have to understand where it sits. Zhangjiajie is not an empty construction lot. It is a UNESCO World Heritage Site, one of the most protected landscapes on the planet, and its geology is the very thing that makes it both beautiful and treacherous. These pillars are quartz sandstone, formed over hundreds of millions of years, and while quartz itself is hard, the sandstone that binds it is comparatively brittle. It fractures, it sheds. Entire faces of these towers weather and fall away over time. Building anything permanent here means anchoring into rock that is, by its very nature, trying to come apart. And this region sits within an active seismic zone, where even a moderate tremor could threaten a structure fixed rigidly to the stone. For engineers, this was close to a nightmare scenario. A remote site, a protected environment, brittle rock, and the constant threat of earthquakes. The solution was a hybrid structure, split almost perfectly in two. The elevator rises 326 meters, roughly 1,070 feet, from the valley floor to the cliff top. But only the upper half is what you actually see. The lower 154 meters is hidden entirely inside the mountain, running through a vertical shaft that engineers excavated directly into the rock. This buried section does something clever. By tunneling into the cliff, the crews turned the mountain itself into a protective sleeve, shielding the lower cars from wind and, critically, from seismic shaking. Solid rock absorbs and dampens ground movement far better than any exposed frame ever could. The upper 172 meters is a different beast entirely. A fully exposed steel derrick, a lattice tower of welded beams standing in the open air, pinned against the sheer face of the cliff. Joining those two halves was the hardest engineering problem of the entire project. You cannot simply bolt a 1,000-ton tower to soft sandstone and expect it to hold. The load has to be carried deep into competent rock, far behind the fragile outer surface that flakes and crumbles. To do this, engineers drilled thousands of high-tensile steel anchors deep into the cliff, reaching past the weathered skin and into the solid bedrock beneath. Those anchors were then locked in place with specialized structural grout, chemically fusing the steel framework to the mountain and spreading the enormous forces across a vast area of stone, rather than concentrating them at a single breaking point. The goal was not just strength, it was uniformity. The rigid rock and the flexible steel had to move as one integrated system under stress, so that no single joint would take the full brunt of a load and shear away. And there is a counterintuitive twist here. The very act of drilling and bolting reinforced the mountain. Like rock bolts in a mine tunnel, those anchors stitch the sandstone together, leaving the cliff more resistant to collapse than it was before construction ever began. Then there is the wind. At more than 1,000 feet, exposed on the open face of a cliff, the upper cars are fully at the mercy of the elements, and wind is the enemy of any tall, slender structure. A gust striking a glass cabin can push it, twist it, and set it swaying, and sway at that scale is dangerous. It stresses the glass, strains the guide system, and in the worst case, can crack a panel. The engineers fought this on two fronts. First, the exposed derrick is a rigid open lattice rather than a solid wall, letting wind pass through the framework instead of catching it like a sail. Second, and most importantly, each cabin is locked onto extremely stiff, custom fabricated steel guide rails that run the full height of the tower. These rails constrain the cars, holding them tight against the structure so they cannot swing freely in a crosswind. The cabins themselves are built from reinforced tempered glass, engineered to flex under pressure and withstand the buffeting that would shatter ordinary panes. It is this combination, a wind-permeable frame and a rigidly guided car that keeps a glass box stable 1,000 feet in the air. Safety here goes far beyond the wind. Because the elevator sits in earthquake country, each of the 3 cabins is fitted with seismic sensors that continuously monitor for ground motion. If those detectors register a tremor beyond a safe threshold, the system does not wait for a human decision. It automatically slows or halts all 3 lifts and moves to evacuate passengers at the nearest safe level within seconds. Backing that up are electromagnetic, spring-applied safety brakes, brakes held open by power that clamp down the instant power is lost. A blackout, an emergency stop, a detected fault, any of these locks the cabins firmly onto their rails. Add overload sensors that refuse to let a car move beyond its rated capacity, and you have a machine engineered to fail safe at every level. Decades of operation with a clean safety record suggest the approach works. Step back and take in the whole picture, and the Bailong Elevator becomes something more than a tourist lift. It is a statement about ambition. It is thousands of tons of German-built machinery and welded steel, fused into a mountain that predates human history, in one of the most fragile and beautiful places on Earth. Everything about it, the buried shaft, the anchored derrick, the wind-tuned frame, the earthquake sensors, exist to solve a single impossible sentence. Bolt the heaviest outdoor elevator in the world to a crumbling cliff and make it safe enough to trust with 50 lives at a time. Whether it should ever have been built remains a genuine debate. But as a feat of raw engineering nerve, it stands almost entirely alone. If you want more deep dives into the structures that push engineering to its absolute limit, subscribe to The Engineering Edge, and we will see you at the edge.